Hello everyone and welcome. Today, we're going to tackle a really useful technique in chemistry. We will learn how to determine a molecule's exact formula using data from a mass spectrometer. It might seem intimidating, but we'll break it down into simple, manageable steps. The first and most important piece of information you need from the mass spectrum is the molecular ion peak, often called the M+ peak. This is typically the peak with the highest mass-to-charge ratio, or M/C value, and it represents the molecular weight of your compound. For instance, if your M+ peak is at an M/C of 94, your molecular weight is 94. Once you have this number, the next step is to find a possible base formula using the rule of 13. This rule helps generate a starting formula consisting only of carbon and hydrogen. You simply divide your molecular weight by 13, which is the approximate mass of a CH unit. For our example of 94, dividing 94 by 13 gives you 7 with a remainder of 3. The whole number, 7, becomes your number of carbons. To get the number of hydrogens, you add the remainder to the whole number, so 7 plus 3 gives you 10 hydrogens. This gives us a base formula of C7H10. Of course, many molecules contain other atoms like oxygen or nitrogen. If you suspect your molecule has an oxygen atom, you need to adjust this base formula. You would subtract the mass of 1 carbon and 4 hydrogens, C1H4, which has a mass of 16, the same as oxygen. So, from our C7H10 formula, we would subtract C1H4 to get C6H60. You can double-check the mass to see it still equals 94. Another great clue is the nitrogen rule. This simple rule states that if the molecular weight is an odd number, the molecule must contain an odd number of nitrogen atoms. If the weight is even, like our 94, it has either 0 or an even number of nitrogens. Finally, you can use the smaller isotope peaks for confirmation. The small M+1 peak, caused by carbon-13, can help you verify the number of carbon atoms in your formula. The M+2 peak is especially useful for spotting halogens like chlorine or bromine due to their unique isotopic abundances. And that's the fundamental process for deducing a molecular formula from mass spec data. I really hope this step-by-step guide was helpful for you. Thank you so much for watching. If you found this video useful, please show your support by liking, subscribing, or leaving a comment below. It truly helps the channel grow and allows me to create more educational content. See you next time.